Okay, part 2 of section 14.3. I left off with the quota rule. The quota rule is kind of a fairness thing. Okay, to be fair, a group should only receive either the upper quota or the lower quota. So a group's apportionment should be either its upper quota or its lower quota. That's fair. An apportionment method that guarantees that this will always occur is said to satisfy the quota rule. The group's final apportionment should either be the nearest upper or lower whole number of its standard quota. All right, Jefferson's method. So we already talked about Hamilton's method. That's where we do the biggest decimal part. Jefferson's method uses a different method, obviously. What we do with Jefferson's method is take what we call a modified divisor. A modified divisor, you're going to guess and check to find a divisor that works when you round everybody down. So with Hamilton, we rounded everybody down. We added it up. There were 29 seats in Congress, and we had one extra. Well, with Jefferson, he says, we're not going to take the largest decimal part. That isn't going to work for me. So what we're going to do is round everybody down. Everybody gets rounded down. But we're going to change the divisor, guess and check the divisor, until we find a number that works to divide by, so that when we do round down, it adds up to what we need it to add up to. Modified quotients that are rounded down are called modified lower quotients. So once we find this modified divisor, find the modified quota, we're going to apportion to each modified lower quota. This will make more sense, hopefully, with an example. So we have a rapid transit service. It operates 130 buses. We've got 6 routes. The number of buses assigned to each route is based on the average number of daily passengers. And the average daily passengers is 65,000. So if we divide that by the 130 buses to be allocated, so we got the total population divided by allocated items, gives us a standard divisor of 500. So we need to find the standard quota. We need to find the lower quota. We don't need the upper quota for this one. So when we take this and divide it by the divisor, we get the standard quota of 8.47. Take 5130 and divide it by the 500, the divisor, 10.26. Remember, this is everybody's exact fair share. If we add them up, you're going to get 130. Again, it's not possible to have 72 100ths of a bus, so it has to be rounded to a whole number. Okay, you can have 8 buses, you can have 9 buses, but you can't have 8.72 buses. So Jefferson says round everybody down. So 8, 10, 14, etc. Well, when we do that, that gives us 128 buses, but we have 130. We're not going to let 2 buses sit idle, so somehow or another, what we have to do is change this number. There's no specific formula on how you change. You're going to guess and check until you find a number that works, so that when you add these numbers up, it adds up to 130, not 128 or any other number. Okay? So 500 doesn't work. The divisor won't work. So we're going to guess a new number to divide by. Okay? Standard divisor isn't going to work. So when this number is too low, we have to lower the divisor. It's kind of a rule of thumb. When this number is too low, lower the divisor. So randomly, we're going to try 475 to divide by. So we're going to take the 4360, and now we're going to divide by 475. When we do that, we get 9.18. Round it down, we get 9. And do that for each one. Okay. So all of our quotas, our lower quotas now, are 9, 10, 14, 21, 32, and 47. Now if we add those up, that's 133 buses. Well, we don't have 133 buses. We only have 130 buses. So this number right here is too big. So this divisor that we guessed, remember guess and check, has to be raised. So this number too big, raise the divisor. But remember 500 was too big of a divisor, so somehow or another we have to pick some number in between 475 and 500. So again, it's just kind of a random guess and check. So try 485. Okay, remember we're just guessing numbers here. When we divide by 485, we now have a new lower quota. 8, 10, 14, 21, 32, and 46. If we add those up, that is 131 buses. Well, we're closer, so that's better, but we still have too many, we're still trying to assign too many buses. So remember, when this number is too big, raise the divisor. So somehow or another, a divisor that we pick has to be between 485 and 500. So we need a bigger number than 485, smaller than 500. So try 486. Okay, we try 486. We take 4360 and divide it by 486, and we get 8. 5130 divided by 486, we get 10. We add these up, and we get 130. So it looks like 486 was a good choice. The final apportionment, Route A gets 8 buses, Route B gets 10 buses, etc. These do take a lot of work. Depends on how good a guesser you are. Adams method. Adams method is exactly the same with one exception. Instead of rounding down, you round up. You still have to change the divisor to make it work so that when you round up, it adds up to exactly how many number of items that we have to be apportioned. Still got 130 buses. Still got 65,000 passengers. The standard divisor, if you recall from the last one, was 500. Without going through a lot of guessing and checking in the notes, somebody else guessed and checked 512. When you use 512, this is upper quota now, so everybody gets rounded up. So 8 gets rounded up, 8.52 gets rounded up to 9. 10.02 gets rounded up to 11. That adds up to 131. Okay, so 131, this number is too big, raise the divisor. Guess another number that's bigger than 512. Well, again, this is something that's already been done for you. When we check 513, it adds up to 129. 129 is too small. We need 130. When this number is too small, we lower the divisor. And you're thinking, hey, wait a minute. We tried 512. We tried 513. Neither one works. So what do? Well, guess a number that's between 512 and 513. And yes, it is possible to divide by a decimal. So yes, when you guess and check, you might have to guess and check decimals. So do some more guessing and checking. We guess 512.7. Now we're going to use this number to divide by. So 4360 divided by 512.7 gives us 8.5 rounded up to 9. Do that for all the routes. Round everybody up. Everybody gets rounded up. This is Adam's method, round everybody up. Then add them up, and you get 130, which is how many buses we have. So this would be how many buses route A gets, how many buses route 11 gets. Or route B, I mean. Webster's method, modified divisor. Modified divisor means guess and check until you find one that works. Webster's method is the trickiest because we use standard rules for rounding. So 0.5 and above gets rounded up. Below 0.5, they get rounded down. Standard rounding for Webster. Again, 130 buses, population of 65,000. Our standard divisor, just like from before, standard divisor is 500. So what we're going to have to do is guess and check a number, a divisor, until we get to 130, but this time we're going to do standard rounding. So we start with a guess of 502. So when we divide by 502, we end up with 129. 129 is too low. So we lower the divisor from 502. Let's try 498. Again, this is not something that is easy. This is easy because the numbers have already been guessed and checked for you. But just try something. Try something until it works. So let's try 498. Standard rounding now. So 8.76 would get rounded up to 9, but 10.30 would get rounded down to 10. So standard rounding now. 0.57 gets rounded up, 0.48 gets rounded down. Add them up, we get 130 buses. So here's our final apportionment. For Webster, this is the trickiest just because of can be rounded up and or down. The others are easier because it gets rounded one way. So it's easier to guess the divisor. Homework 2 through 18 even.